Hi guys, so today's lesson we'll be looking at molecular shape and how this relates to its properties. So the molecular shape is really important in giving us an indication of how it interacts with other molecules and therefore its physical properties. So physical properties include how well it dissolves in water, its melting point, as well as its boiling point. So today we'll be focusing on the Lewis dot diagram. So Lewis dot diagrams are a way to show atoms, such as oxygen and sulfur, its bonding electrons, represented by the lines, as well as its lone pair electrons, so ones that aren't involved in bonding, denoted by the dots. So they give us an indication of how the electrons sit around the molecule. So properties of substances are directly related to structure and shape of the molecule. So we can use Lewis dot diagrams to show us how they bond and also the electrons involved. So each atom and its valence electrons, so the electrons in the outermost shell, as well as its neighbours in the picture. So in this case we have sulfur and its neighbours are all the oxygens around it. And also we show the valence electrons with the dots and the bonds, like we said before. So bonding pairs are shown, and also how many covalent bonds are formed are shown. So covalent bonds are bonds where the electrons are shared between two atoms, and they're represented by lines. So a double bond is represented with two lines, and a single covalent bond is represented by one line. Also, they show the lone pairs. So lone pairs are ones which aren't involved in bonding, and they fill up the outermost shell of an atom. So lone pairs are shown here and here. But Lewis dot diagrams, even though they show us so much information, they don't give us any information about the shape of the molecule. So they only show bonding, so single bonds represented by two electrons. Two electrons are involved in bonding, not more or not less. So a single bond has two electrons. A triple bond has 6 electrons because there's 3 sets of pairs. A double bond has 4 electrons because there's 2 sets of pairs to make a double bond. Lewis dot diagrams also show non-bonding electrons. So non-bonding electrons are also called lone pairs, and they're denoted here by 2 dots. So now that we know what a Lewis dot diagram is, we can now go ahead and start drawing them. So the first step is to place the atoms relative to each other. So how do they sit in comparison to each other? So in this case, we're going to be looking at nitrogen tetrafluoride, or NF3. So there's one nitrogen, so that's going to be the central atom, and it's going to be surrounded by 3 fluorine atoms. So we're going to place a nitrogen in the middle, surrounded by 3 fluorine atoms. In step 2, we determine the total number of valence electrons involved. So a valence electron is the electron that's in the outermost shell. The outermost shell are the ones that are involved in bonding. So for nitrogen, we have 5 electrons in the outermost shell, shown there. Fluorine, however, has 7 electrons in the outermost shell, shown over there. But in NF3, we have 3 fluorine atoms. So that means we need to times it by 3, and then, so 7 times 3 gives us 21 electrons, plus the 5 electrons from nitrogen, and that will give us 26 electrons in total involved in bonding. So step 3, we need to draw a single bond from each of the surrounding atoms to the central atom, because it's bonding together. So that's shown by a line here. First we have two electrons. 2 electrons form a bond, and we draw a line. So we're going to connect 3 lines from the nitrogen to all the fluorine atoms. We then can subtract 2 valence electrons from the total ones. These will account for all the bonds. Because a bond has 2 electrons in it, and there are 3 bonds, therefore 6 electrons are involved in bonding. So, in step 4, we subtract 2 electrons from each single bond, which we already just went through, And take this away from the total number of valence electrons to find the remaining amount of electrons involved. So we had a total amount of 26 electrons, which we added up before. Then we have 3 bonds. 3 bonds means 3 sets of pairs, and that means there's 6 electrons in bonding. So 26 minus 6 gives us 20 electrons. So the remaining 20 electrons are not involved in the covalent bonds which we drew the lines for. So we then have to distribute them amongst the atoms. So we distribute the remaining electrons in pairs so that each atom will then have 8 electrons in its outer shell. The outer shell has a maximum of 8 electrons, and this requires it to be stable. So to construct the molecular shape from the Lewis dot diagram, we can then use the valence shell electron pair repulsion theory to determine its molecular shape. So these are Lewis dot diagrams of water, ammonia, and hydrogen sulfide. And using these, we can then apply the VSEPR theory to determine its shape. So in summary, we just looked at how to draw a Lewis dot diagram. So quickly to recap before we do the question, we have to figure out how many atoms are involved, how they relate to each other in space, how many electrons are involved, and then how do we distribute them minus all the bonding. So with that, we can do the question. And first of all, it asks to draw the Lewis dot diagram of water. So water is H2O. So there's 2 hydrogen atoms plus 1 oxygen atom. So if there's 1 oxygen atom, it's most likely to be the one in the center, surrounded by 2 hydrogen atoms, which we can see here. So a hydrogen, if you look at the periodic table, will have 1 electron, and it can be this one, which I've circled. So each hydrogen has 1 electron each, and if you look at the periodic table again, oxygen will have 6. So that's 1, 2, 3, 4, 5, 6. So to do a bond, we add 2 electrons together, 1 from the hydrogen and 1 from the oxygen, and we make a line. We do the same thing for the other hydrogen and draw a line. So we now have 4 electrons which have been taken up with covalent bonds. So that means 8 minus 4 gives us 4 electrons left, and we can distribute them around the oxygen atom in lone pairs, here, 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 and here. So that's how you draw a Lewis dot diagram for water. It's really simple for water because there's only 3 atoms, but it can be really complicated when you have lots of other ones. So we'll try another one. Question 2. Draw the Lewis dot diagram for ammonia. So ammonia is NH3. So because there's 1 nitrogen atom, it's most likely the one to be in the middle, surrounded by 3 hydrogen atoms. So each hydrogen atom, as we said in the previous question, has 1 electron. So 1 electron from each hydrogen. If you look at the periodic table, nitrogen has 5. Five electrons. So in total, we have 8 electrons. So 1 electron from the hydrogen plus 1 electron from the nitrogen gives us a covalent bond, which we can draw a line for. And then we repeat it for each of the hydrogens. So we get lines for all of them, showing covalent bonds. So each covalent bond has 2 electrons, like we said before, and so we have 3 covalent bonds in total. That means we have 6 electrons in total involved in covalent bonding. So we had 8 electrons in total, minus the 6 involved in covalent bonding leaves 2 electrons left. So the only other place we can place them is on the nitrogen, because hydrogen only has space for 2 electrons in its outermost shell. So the lone pairs go on the nitrogen atom. And that's how you draw the Lewis dot diagram for ammonia. So in question 3, we need to again draw the Lewis dot electron diagram for beryllium dichloride. So beryllium dichloride, BeCl2, has three atoms, and because there's 2 chlorine atoms, it's most likely that the beryllium is in the middle. So the beryllium has 2 electrons in its outermost shell, represented by the dots. The chlorine atom, if you look at your periodic table, should have 7 in its outermost shell, represented by all the crosses. So covalent bonding involves 2 electrons. So a covalent bond is here and here. 1 electron comes from the chlorine atom, 1 electron comes from the beryllium atom, and the same on this side. So then we have 6 electrons left from the chlorine, which we can then distribute around the chlorine atom to give us 8 in the outermost shell, and again on this side. So next, we need to state the number of electron pairs in the valence energy level of the central atom. So the central atom is the one in the middle, and it's the beryllium. So in the valence energy level, that's the bonding level. So that's the outermost shell. In the central atom, we have 1, 2, 3, 4 electrons involved in bonding. And therefore, we have 2 pairs because there's only 4. Next, we need to state the number of atoms bonded into the central atom. The central atom is bonded to 2 chlorine atoms. Therefore, the answer must be 2. So next, we can look at question 4. Draw the electron-dot diagram and give the formula for hydrogen and iodine which combine together to form a covalent molecule. So hydrogen is denoted by the H symbol, and iodine by the I symbol. So together, if they form a covalent bond, they form a molecule HI. So to draw the electron-dot diagram, we know that hydrogen has 1 electron in its valence shell, which I'll just draw here. Iodine has 7, which I'll draw here. So in a covalent bond, we have 2 electrons. So 1 from the hydrogen and 1 from the iodine bond together to form the bond here, represented by the line. We then still have 6 electrons left from the iodine, and we can distribute them as lone pairs around the iodine. So because we know H and I are the symbols for hydrogen and iodine, the formulae would be HI. So the last question, question number 5. Draw the electron-dot diagram and give the formula for carbon and fluorine which combine together to form covalent molecules. So carbon is represented by C. Fluorine is represented by an F. When you look at the periodic table, carbon will have 4 electrons in its outermost shell. The fluorine should have 7. Because the outermost shell of carbon has 4, it means that it can bond 4 times to make 8 electrons in its outermost shell. So carbon will be in the center, and it will have 4 electrons in its outermost shell. For it to get 8 electrons in the outermost shell, which is what's required for bonding, it needs to bind therefore to 4 fluorine atoms. 1, 2, 3, and 4. Fluorine, we know, has 7 electrons in its outermost shell, and therefore it only really requires 1 more to make a bond with carbon. So fluorine has 1, 2, 3, 4, 5, 6, 7 electrons, plus the 1 from the carbon gives us 8, and therefore the valence shell of fluorine is filled. If we do this 4 times, then the carbon one will have 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost shell, and that's what we need. So the formula for this one will be C, F, but that requires 4 fluorine atoms, so CF4. So in summary, we just looked at how to draw electron dot diagrams, and they show us a lot of information about bonding and the electrons and how the atoms sit relative to each other. And they also give us an indication of how many lone pairs, but they don't give us any information about how the shape of the molecule looks like.